Just want to say good morning to everybody. We've just got 1 or 2 minutes before we start, so hopefully you can hear me, and please let me know if you can't, and I'll just adjust the volume on the microphone. So I'll just get started. I'll introduce myself. My name's Richard. I'm a message broker and Java developer and author of the MB Precise plugin that we'll be doing this presentation on, or this webinar on. So we'll just jump into the agenda and have a quick look at what we're going to cover today. So first off, thanks for everyone for joining us and taking some time out of your busy days to watch our little webinar, and hopefully have some food for thought, or maybe learn some things about Sonar and Jenkins that you might not have come across before. So what we'll be covering today, just before we do the demonstration of the MB Precise plugin and Sonar and Jenkins together, we're just going to have a quick chat about what we're actually trying to achieve with this set of tools and with the product. So what is it we actually are trying to do? Now, different people will have different opinions on this, or take different ways of describing it, but I like to describe it as, from a business point of view, is writing cheap code. So, and what do we mean by cheap? So when we say cheap code, we don't mean we hire the cheapest developers we can find and we give them the poorest equipment we can do and expect them to do their jobs. What we mean by cheap code is code that's bug-free, is easy to understand, performs well, can be changed and can be tested, and does its job. So essentially what we're talking about when we're talking about writing cheap code, we're talking about cheap code for the business, because changes to the code can occur quickly and efficiently and effectively. When people change the code, they have a fair degree of confidence that the code changes won't break anything or cause production issues or issues with customers, which can be quite costly. Essentially, we're talking about writing good code. So if we came from one of the other development languages, or some of the more common development languages, we'd have a lot more tools at our disposal to help us with writing good code and clean code. So we're just going to have a quick look at some of the other tools available in other languages. Just make sure that no one's trying to chat. No. So if you have any questions, just jump in the chat and just either jump in the chat and just raise your questions, or send me an email. So some of the tools at our disposal, if we're running in, say, Java or Scala or C# or VB or even COBOL. Well, maybe not COBOL, but some of the tools, particularly in the Java space, we've got something called FindBugs, which is essentially a static code analysis tool, particularly for Java. And what it does is it goes through your code and provides or applies particular rule sets to try to find essentially bugs, or poor coding practices, poor code performance practices. And so what you could do with FindBugs is you run FindBugs against your code, and it will tell you when you're doing things potentially wrong, where you're casting from a larger type to a smaller type, where you're using equals on strings instead of the correct equal method, things like that. So it's programming practices that cause potential bugs. Another tool at your disposal if you're writing in C# or Java is something called checkstyle. So checkstyle is a tool, again another open source tool, that analyzes your source code and tells you where you've deviated from a predefined set of coding standards. So these coding standards could be line length, it could be type and character of variable names. So variables, constants should be all uppercase. Regular variables should be all lowercase. Variables should be camel case. Function names should start with lowercase letter. Procedures and functions should only be a certain length, so there might be a restriction on the length of them. Indenting should be applied, and some of them even provide spell checking. So generally, it's trying to help you make your code readable for your developers. So PMD is another particular Java and other languages type tool. Very similar to find bugs, but just with slightly different rule sets. So it again analyzes your code, but it does a few extra things. One of the things it does is support something called CPD, or copy paste detection. So essentially what it's doing is it's working out, it's analyzing your code and looking for where your code is actually duplicated. So it could be a duplicated method, it could be a duplicated block. So what PMD, or one of the tools that PMD is trying to do with this CPD, is trying to limit the amount of copy and paste that developers are doing, which is many consider one of the cardinal sins of a developer. So the more copy and pasting you're doing, the more you're actually writing code that potentially needs to be tested, because not only if you had written that particular piece of code as a function, then the function only needs to be tested once. But if you're copying and pasting code around, then each path through the code or each set of the same code needs to be tested to get confidence that the code's going to perform. It also causes maintenance issues where the same change or a change to a particular piece of code might actually need to occur in multiple places. And a source of bugs is that not all the code changes happen. So a particular testing path isn't used very often, or a particular execution path isn't used very often, hasn't been tested, and once in a while causes a production issue because it was never updated with the other copies of the code. We'll just stop for a second. Does anyone have any quick questions before I continue on? Right, so that's PMD. We'll just discuss a few other terms just quickly. One is called technical debt. Now, technical debt is attempting to turn what we consider the accumulation of bad code into an accounting term. So what we mean when we talk to the business or to project managers or to customers about technical debt, is really referring to the amount of work or the amount of extra cost in the future that we will have in maintaining and enhancing our software that is caused by particular decisions we've made today. So maybe a good analogy would be if you're a car designer or a car builder and you said, look, I can build you a car with 3 wheels that will get you where you're going in an hour, which will get you home or get you to whatever you need to do within that hour. But I need to take the car apart and put the 4th wheel on, because if you wanted to go twice as far tomorrow, it's going to take you twice as long. So it's the pay back we need to give back to our code to make it as changeable as possible, or as changeable as possible in a cost-effective way. Continuous integration. Continuous integration is part of the Agile movement. So continuous integration is a practice in software engineering where we continuously as a team integrate all our work together, test all our work together, and deploy our work together. Ideally through some sort of build server or build chain or build pipeline, so that when we know we make a change, that we've made a change that's going to be consistent with everyone else's change, and that we haven't stepped on each other's toes. And then our work with our co-workers and our other teams is going to work together. And we want to do that as often as possible to avoid any long-running integration issues down the track when we go into a test environment. Continuous delivery is a way of looking at developing software such that when we're building software, building it in small releasable chunks with the business, so that we're maximizing business value by producing software that can be released as often as or frequently to fulfill our business needs. So what this means is when we apply a change to our code, we apply the change, we code review it, we integrate using continuous integration, we test it, we performance test it, and then we know it's ready to potentially be released via some mechanism out to the customer within a reasonable amount of time after our code change has happened. So it's sort of the exact opposite of what previously would have happened years ago in large teams, where one team would work on a piece of code for months at a time, and another team would work on a different piece of code months at a time, and at the end of the 6-month period, they would try to put their code together to make it work, so that they could put into an environment to test. The last term we're going to talk about here is something called snowflake setups, which I believe was coined by Martin Fowler. But essentially it's just capturing not only your code in, say, a version control system or a repository, but also the configuration and deployment settings required to make sure that when you deploy code or when you deploy applications into an environment, or set up applications into an environment, that you get a consistent outcome each time. So what we're saying with this is, every time you build the code, you should be able to know what's in it, and you should be able to know that with a certain amount of confidence that it's going to work if you redo the same thing with the same artifacts. So what we're trying to do with them is Snowflake or Snowflake server, because we don't want to be producing snowflakes. We want to be producing exactly the same thing from the exact same inputs each time in a consistent way. And this last article here is just a discussion around SonarQube and development operations, and getting a continuous delivery environment or continuous delivery process set up with Sonar. So the reason we've been covering these terms is to introduce to what we're trying to do, and what we're trying to do with the MB Precise product is bring the find bugs, Checkstyle, PMD tools into the message broker world. So we call it find bugs, PMD, and Checkstyle for message broker developers. Are there any questions? Right. Well, we'll keep moving forward. So that's what we're trying to get to. So we'll start. Next, we'll have a quick look at what SonarQube looks like. So SonarQube is a number of different components. It's a dashboard, and it's a database with a server behind it. So essentially, what Sonar does, or SonarQube does, is it goes and runs or I should say, it goes and collects metrics and what we call metrics, what we call violations about code from whatever framework's in place to actually generate those metrics, collects those metrics at a point in time, and then stores them in the database so that we can go back and look at the combination of metrics and what we call violations at the current time, and also look at it historically to work out whether there's been an increase or decrease in the quality of our code. So Sonar splits things into two parts. As I said, one thing's called general metrics and violations. So we'll have a quick look at metrics first. So metrics are general numeric information about our code. So it could be, in the case here, it could be the number of files that make up our project, the number of lines of code, the number of statements, the number of directories, just numeric information, which doesn't necessarily mean it's good or bad, but just gives us a gauge of how our code is developing over time. So they're the general metrics. Now, as part of the MB Precise plugin, we've developed some custom metrics for Message Broker specific code that provide information to your developers and architects about a little bit more information about the quality of your code and whether or not you're conforming to standards, or whether or not you're seeing any dramatic changes in these metrics that could indicate that there's been a change in coding style, or there's been a decrease in quality. So the numbers per se don't mean much, but they help infer information between the combination of what we know about the developers, or the developers doing, and the other metrics and the code we're trying to write, or the architecture we're writing towards. So the first one here is just the general number of nodes. This is the number of component nodes in our subflows and message flows. As I said again, that doesn't tell us too much. It does allow us to drill into our count of nodes, and it does allow us to look at what particular message flow has the most nodes. So in this case here, we can see that the request with aggregate has the most. So has the most nodes. So if we just go here and we go request with aggregate, we can see it's a very complicated flow. So as I said, this particular number doesn't mean much, but when we drill into it and we look at which flows have the highest number, it gives us an idea of our complexity, and whether or not our most complex components within our system needs to be refactored, or whether or not we're happy with this. So we might look at this and say, okay, well, this particular flow is used very rarely, so it's not an issue that it's complicated. Or we might say this particular flow is used quite often, and hence we might want to look to refactor some of it for efficiency or performance reasons. Again, MQ, again, another metric that doesn't necessarily mean much is MQ. Doesn't mean much in isolation is the number of MQ input nodes. This is telling us basically how many queues we're accessing, or how many queues we're accessing through our application. So if we're generally writing applications and don't do a lot of queue processing, and this number starts increasing, then we might start looking at it, might start looking to track that number to make sure that people aren't developing applications using queues when they potentially should be using some other form of input. Probably the most interesting one from the node, the counts of nodes, or the metrics around the nodes, is the number of RCD nodes. So RCD nodes are known to be have performance issues. So in this case, what we've collected here is just the general number of RCD nodes in the system. So if we know that they generally aren't being used, and we see an increase in the number, then we might have to start looking at why those particular RCD nodes are creeping into our application, and whether or not there's alternative ways that particular logic could be developed, or whether or not that particular flow that it's in isn't as performance critical as potentially other ones. Another useful one here is this flow length. So what we're saying here is, while we had a count of the number of nodes, which gives us a general complexity, the flow length gives us the maximum path through any individual flow, and this by having it as a metric, it allows us to drill down and pick the one with the highest and have a look at it. So in this case, we're looking at something called backlog 6 long flows. So we go into our message broker toolkit. We see backlog six long flows has a longest node chain count of 10. So we can see here that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We can see here that there's a path that has a maximum of 9 nodes being executed in sequence to fulfill this particular flow. So again, this doesn't actually mean anything just on its own. We'd have to look at how this flow is used, whether it's used regularly, whether or not we're expecting it to handle a large number of messages. We might decide that that's not an issue. The flow length is not an issue from a performance point of view because it only handles 1 message a month. Alternatively, we might look at this particular flow and determine that it's used quite often. We might know that it's used quite often, and then we might consider tuning it or making it perform better to improve the overall throughput and health of our system. Another couple of interesting metrics. So we've got something called cyclometric complexity. So in this case here, we're talking about cyclometric complexity of SQL, and cyclometric complexity is a general measure of the number of executable paths through a piece of code. So what we're saying here is this is giving us a estimate of the overall complexity of the ESQL code in our system. So if we look here at our psychometric complexity, and we look through, and we see that there's something called airline XML has a complexity of 36. So we go into, oops. Okay, this is actually in a different, this isn't the most up-to-date project, but we can drill into Sonar. And we can go into the code, and we can see here, we can have a quick look through the code. We can see here there's one normal path through the code, which is just because we have a beginning and end, so that's a complexity of 0 because there's no alternate paths. And then we can see here we've got a while loop with a nested if, and within that is another nested if. So we can see, we already see that here we've got an additional cyclometric complexity of 1 because of a loop, another path through because of an if statement, another path through because of that if statement, another alternative path through for something else. So we can see how the number of paths through this piece of code adds up. And it's that accumulation of paths through the code that adds the complexity to the code and adds the number of increases the number of testing paths. So we might be looking to have a look at this, a refactor this particular SQL to see if it could be structured differently to prevent to decrease the complexity. The other option is it gives us an opportunity to, or identifies an opportunity for us to address how our tests are running, whether or not this has been sufficiently tested given its complexity. Next one we're going to talk about is something called string manipulation load and weighted string manipulation load, and they're quite similar concepts. They just implement slightly differently. So string manipulation load is just a summary of the number of string operations within the SQL. So in this case here, we'll look at the one with the most. That's a count of 9. So what we're saying in here, we have 9 ESQL string functions. So we can see here there's we have a length, we have a position, we have a couple of substring functions, we have a string length in here, and fields, and so on and so forth. So what we're saying here is this particular SQL function does more string, it does the most string work of any function in our system. And this gives us an idea of whether or not we might want to change the code, try and refactor it so it does less, or we might try to choose another implementation strategy, like we might decide to replace this with Java and irregular expressions, for example. So again, it doesn't say that the code is bad. It just gives us an indication that we might want to further investigate. So that's string manipulation load. Now, weighted string manipulation load is related, but it looks at not so much individual string functions. What it tries to do is tries to give you a higher weighting for string manipulation that's going to occur in an iteration. So it gives you a higher rating, the number of, or a higher score for the weighted load by the depth that the particular function is within the code. So in this case here, we have a while loop. In that while loop we have some string functions. Last move. In the while loop we have, let's have a quick look. So we're just looking here to say, we're just looking for where it's actually manipulating strings with that within a loop. Trim, okay, for example here it's saying give us the high load because we've got a trim within a loop. So if we know that this particular message is likely to only have a few elements, or this particular table is extracting data from only has a few elements, then this is going to be isn't going to be an issue. But if we know that this particular table or the message that this loop has been running against has a large number of elements or a large number of records, then this could be a potential performance issue down the track, either when we go into a production environment or when the amount of data or the size of the message changes. The last one is the complexity of a psychometric complexity of a map. So if you look here, we're looking at a for example, a map file with a complexity of 0 basically just means it's a straight through map with no additional logic. In the case here, we're looking at a more complicated map. We can see there's lots of different paths through the system. So there's a filter, there's a for each, there's some if conditions, there's a test, another condition, and if. So we can see here there's multiple paths through this map that could be chosen for any particular element, which is why the complexity score for this particular file is so high. So we'll just stop there for a second at the end of violations. Does anyone have any questions? Okay, so we'll keep going. So that's the violation side of things. The next one we're going to talk about is the is the metric side of things. The next thing we're going to talk about quickly is the copy-paste detection. So we were saying before that PMD provides for copy-paste detection. So within Sonar, within the plugin within Sonar, we've developed a copy paste detection for SQL. So essentially, that's collected here in the duplications widget, so we can see that it's got a score, and that number per se isn't necessarily good or bad, but we would generally go with the general rule of any large increase in duplications is bad. So we might look to keep it at a reasonably known level. So we just jump into duplications. We can see that, for example, this one here has got 83 lines of duplication. Compute requested legacy approved task. And there's another file, compute, which has exactly the same code in it. So it's telling us that there's 83 lines of duplicate code in this function. So the whole function is actually duplicated. So it's not. There is one thing to take into account when reading through the duplications, is that by the nature of the way the copy message headers and copying time messages work within Message Broker, you do get a certain amount of natural duplication, because those are proliferated throughout most SQL files. So a duplication of 4 lines may or may not be valid, might not be a concern. If it's just the fact that the copy message header is duplicated, then that's just part of the course. But if it's 4 other particular lines of real logic, then that in that case it may actually be an issue. So that's metrics and duplication. So we'll move on to our violations. This is probably the more interesting thing, or the more interesting component of Sonar. So essentially, a violation is where we've recorded an issue with the code for some reason. So the issue could be, or a potential issue with the code. So it could be a logic error, or it could be a complexity issue, it could be a style issue, or it could be a potential performance issue. So at the moment, we've got about 167 different violations for various coding practices within Message Broker. Sonar Cube collects them together and allows you to display them according to a particular priority. So we've got blockers, critical, major, minor, and info. So if we jump into the quality profiles, we can see that we've got, in this case, we've got 158 rules turned on, and we can see there's a summary of all the rules with their levels, with their priorities. So I can just talk about a few of them just quickly, just to give you an idea what sort of checks we are doing, and then we can go through how they look in Sonar, and then you can have a bit of a play once you've had a chance to download the trial version. So some of them are related to particular components within Message Broker. So for example, this first one is saying that you haven't included the properties in a map. So this might be on purpose, but it most likely means that the properties aren't being passed through. So the properties won't be able to be used downstream. A column being referenced is not being found in the DB schema. So within when the MB Precise static code analyzer runs against your Message Broker code, it tries to build up a model of the database usage within your code. So what it tries to do once it's got that database usage is you can provide it with a read-only database connection, ideally to a development database. It's very much like production, or very much like the code you're running. And what this allows it to do is it allows it to check the database usage from the code and the logic of the database structure in the code against the actual real database. So in this case here, this is saying that this check is that a column has been referenced, but we cannot find it in the database. So more than likely, this is a bug. So we may have misspelled the column, we may have dropped the column, we may have not added the column, we may not have added the update script to our release process. So even though we know the columns in one database may not be in the real development database because we haven't released it yet. So there's a couple of different reasons why we might be getting this particular violation, but essentially the violation is trying to save you the time of deploying into an environment and then eventually hitting whatever condition that causes that SQL to run that references a column that isn't there. Again, relating to databases, this is saying that there's a column being referenced, in particular update or a select statement, and there's no index on it, and that the analyzer expects that it's going to be a performance issue. It may not be a performance issue because due to the size of the table, but there's a potential there. This one here, if subflow has been created but is not being referenced, this is just an indication of potential dead code. So someone might have been using one particular type of subflow for a piece of work, and it may have been deprecated and maybe replaced with another subflow, and the original subflow is still hanging around the system. Deprecated terminal. There's a couple of different components or nodes within Message Broker where that's recommended not to use a particular terminal. So it's just saying that the terminal's been used in the code, but it's recommended that you don't. So this is doing XSL or checking of XSL files to say that there's a variable declared but not used. So it could actually be either dead code because it's not being used, or it could potentially be a bug where we just haven't read from the right variable to produce a result. The next rule is the opposite of that, I guess you call it, where you're saying that you're trying to use a piece of XSL, but the variable's never been declared, which could mean that you're always going to get an empty result regardless, so which is a potential bug. Atomic references. Atomic is for dealing with ESQL, where you have atomic sections within the code, and I guess it's the equivalent in Java world of a synchronized calling a synchronized block. You've got a potential deadlock. So the plugin's identified that there is a path through the code where this atomic block could call that other atomic block and lock. Performance violation. Avoid using cardinality within loops. Naming conventions around your MQ. This one here is saying that all your backout queues should have the same name with the backout in front appended. Bitstream is deprecated, saying use as bitstream instead. Again, another MQ naming convention. Backout queue name and backout queue threshold should be defined. Case statements with no alternate or default path, which could be a potential coding error. When statement with only one condition, which could be just logically replaced by an if, just reads better, just a coding style thing. And so on and so forth. So we can go through all of them, but there's a fairly good breadth of checks it's doing for the Message Broker code. As I said, against performance, against logic errors, against style, against the deprecated code or deprecated usage, and style. So, for example, environment variable should be the variables subtree. A style issue. Yeah. Okay. So that's the violations. So when we go into when we run the analysis, which we'll just do quickly. So essentially, what we're just going to do is just run a quick report. We'll run the analysis report. So this is just running on my desktop. Essentially, what it's doing is going through the code. It calls out to something called Sonar Runner. Sonar Runner connects up to Sonar and then just asks Sonar to analyze the code, feeds the code to Sonar and just says, can you please analyze it, and stores the results. Now, we did actually get an error at the end of that, but we'll explain that error in a second. So what it's done is it's published the results, which we'll just see here. Well, just says that last analysis was now in Australian time. So we go in, and then we can dive into our issues. And there's different ways of navigating around the issues, by issue type, by component. So, for example, here we'll just jump into this particular issue. So, saying that the file is empty. So, if we go into so we jump into the issue, jump into the file. We see that there's nothing in the file. So it's giving us a number of violations around this particular file. One to say we're not using our default schema, which is actually configured in your property file. So you can set it to whatever your basic schema name is going to be. Telling us we haven't set up our standard header with our author version and date. It's telling us that the file's empty. We're also telling us it doesn't contain our standard company name, which is Bridges Test Company, which again is configurable in the property file. And that property file is that property file just looks like it's just a property file with some setup information. So this tells us what that project actually should be called when it's stored in Sonar. This allows us to configure our database connection for when we want to check our database access from our code. This is our default schema. This is where we're going to generate our diagrams into, and a few other thresholds for our complexities and our line length and things like that. And these are all configurable per project. So that's an example of some violations being shown up in the Sonar dashboard. And there's various tools after this and various plugins that work in the Sonar ecosystem. So from there you could flag it as to say it's not being fixed. You could raise a JIRA against or some other, say, TFS action against it, and sign it back to the developer to fix. Or you could produce some sort of PDF reporting from it. So that's the violations and metrics. We'll quickly go into the Jenkins component and the continuous integration, continuous build. So what we've got here is we've got some code that we've analyzed through Sonar, and to be useful in our day-to-day work, we want to look to see if we can make this a part of a continuous quality process. So rather than just the developer making some changes, Sonar telling us that they didn't conform to the coding standard and wait to someone to do actual physical code review. In which case, in most organizations, by the time the code review comes around, it's too late to make any changes and do the retesting or the regression testing. What we're looking with Jenkins and Sonar is to build a continuous quality framework where when developers check code in, we run the analysis of the code and give them immediate feedback of the quality of the code. So in the case we're going to be using something called the build breaker. And what that means is when we run our Sonar analysis is the build breaker actually tells us when we've violated our coding practice, our quality gates. So a quality gate is just a line in the sand of what our minimum quality is going to be. So in this case, we've got a fairly artificial quality gate. So we basically said we're going to warn when we have more than 10 critical issues, and we're going to fail when we have more than 20 critical issues. So what we've set up is Jenkins, SonarQube, and our developers. So in this scenario, a developer makes a change, they check the code in. What we have here for our Jenkins job is we can configure our Jenkins job to actually poll our database for check-ins. I haven't done it because often this laptop runs offline, but for argument's sake, you can configure Jenkins to pick up, to poll the source code repository, or build periodically in the end of the day, every morning. So what we could say is poll. We could poll the data. We could poll every 10 minutes to look to see if there's any developer changes. So say our developer has changed it, and that causes our job to be triggered. Essentially our Jenkins job would build, and we put whatever build steps we'd like to put in there. So if you're building a continuous integration environment, what you might do is run the build and deploy it somewhere for testing, or in this case, what we might do is run our Sonar analysis first to make sure our code quality is of a high enough standard. Then we might move on to doing an automatic build of building the component bars, and then a deployment of those component bars, and then ideally some sort of regression testing against that deployment in a static environment. But we're just going to do the first part of this step. All those steps, which is basically running the Sonar analysis. So we can see here that our Sonar analysis has failed. So in our real-life organization, what we might do is set up our post-build actions with a email notification for every failed build. So what we might do is when the build fails because of the quality is dropped, we might email our development team. So in this case here, we can see that the build has failed. And we go to the output. We can see that the build has failed because the critical issues is greater than 20. So we go back into Sonar. We can see that our analysis is run. It's now 5 minutes later, but we've got this big red dot or big red cross there, and that big red cross is indicating to us that the build is actually broken because we've failed one of our quality gates. So it's very rough. What we're basically demonstrating is you can have a continuous code quality inspection framework based on Jenkins and Sonar that gives you feedback to the developers when the developers aren't, or when the code quality drops, and it gives you the automatic feedback, and also gives you the automatic. It gives you that gate, where the gate prevents you from releasing any software until the quality is kept to the minimum standard. So in the last couple of minutes, I'll just quickly see if there's anyone got any questions. In the last couple of minutes, we'll go through what we call additional component we've built for on top of the plugin, which we call the diagram component. So essentially, most organizations have some sort of overall architecture that they like to code towards, or that someone envisioned. More than often, someone does some nice Visio diagrams or some enterprise architecture diagrams, prints it out, says this is our architecture, and that's left as is. Whether or not the application is consistent with that architecture, or whether or not that architecture diagrams get kept up to date, a lot of organizations don't worry about it. So what we've done as part of this development process for this plugin is we've developed these diagrams. So essentially, at the end of the analysis process, we generate a set of HTML documents that include some SVG diagrams. So what we've done here, and what I'll just open up here, is we've just got a web server running. I think it's the Mongoose web server, and it's running just on my desktop here. And we can see here that we've got some generated diagrams, and this one's listed as the half an hour ago. So what we can do is we can go to our browser. We can jump onto the page and go into the generated diagrams. So what this diagram here is showing is this is an interactions between all the components based on the input and output queues. So what we can see here is, for this one particular down here, for example, is that is this particular flow consumes a message from queue defined 1, and there's nothing in this system that's actually producing messages for queue defined 1 that the plugin can identify. It doesn't mean there isn't something in the system producing messages, but it's not within the message broker code, the data power code, or the Sterling code that it found and analyzed that it could identify. So it's just so our little diagram here is just saying a queue feeds a flow, and we don't have a description on the message flow. So not all that useful. What we're seeing here is in this particular diagram is we've got a message flow which is consuming a queue from something called DC queue. It's writing to the same DC queue, and then it's also writing back to itself. So in the case of our diagram here, we can see that, oops, let's see if we can scroll across. So I might just, we can see here that this particular flow doesn't seem to make a lot of sense. We might want to look at refactoring that. Otherwise, we can look at some of these other flows here. So we can see, for example, that this particular flow consumes messages from one particular queue, and then it produces messages to either one or both of these queues. So it produces messages for either the drawing 5 message flow and the log message flow, or the drawing log message flow. So this sort of diagram is intended for people to understand the system, but it also might be more opened up in an organization to people that say do production support, or people who do release management or configuration management, because they might need to know where which particular components flows come into, messages come into, and which components messages come out from. So that's the general architectural diagram based on queue consumption. Then we've also created a summary. So this summary, in this case here, this summary is just a summary of all the particular message flows within the code that we've identified, and some comments and documentation that we've found. So where you've documented something added a note to the message flow, we've captured that here for all the flows in the system. As a summary of all the flows, we also look at a summary of all the queues. So in this case here, we're listing all the queues by name, and then we're also listing the flows where the queues are used from. So in this case here, we might want to jump into a particular queue. I can see that this particular queue feeds backlog 6, and that in turn feeds logging errors, requests, and messages. This one here we'll spend a little bit. We'll try and spend a little bit more of our remaining time on. So this is the extracted SQL summary. So this helps feed into the column and table name checks violations, where we pull apart the SQL, look at the database table, look at the columns, look at the indexes, and work out whether or not we need to warn the developer that might be doing something either that's going to cause a bug because the column doesn't exist, or the column name doesn't match, the table doesn't exist, or the index may not be appropriate. This is something that we'd looked for teams to publish out to their DBAs. So what we have here is we have an extracted version of what the SQL would look like if it has been run, if it would be run by the message broker. So this particular I guess summary isn't trying to replace the tools that DBAs might use on in their everyday work to identify potentially SQL that's poorly performing or consuming a lot of resources. It's ideally there to supplement it, because although those DBA tools are quite useful, they only tell you the SQL that's actually running, while the intention of this gives a summary of the SQL that potentially could run. So this allows our developers and our DBAs to sit together, have a look through the SQL that's being constructed, and look at whether or not it is well formed, whether or not it's performs well, whether or not there's any tuning, and basically it gives the DBAs an insight into how developers are using their databases. And whether or not there's either something that they need to discuss with the developers about how they're doing it, or something they can help developers with. The rest of these tabs are, again, summaries. So this is a summary of the data sources being used and where. So if you've got multiple database accesses, just give an indication of what databases are actually used by which parts of the system. Some flow properties, so which particular flows and subflows have, which particular message flows have propagated properties that you need to make use of. This one here is a summary of all the common ESQL that the analysis could find. So basically ESQL code that looks to live outside of your normal module, compute module, filter module, database module type code. So if we look here, so we're saying it's there's a bit of common code called test duplications in the code duplication CSQL file that people might want to make use of. So this is to help build out a a library for new developers, or developers that might be looking to try and work out what common functions are available that they could reuse rather than reinventing the wheel. The Java method is just a summary of the Java methods being used. Stored procedures, a summary of the stored procedures that ESQL will be going off and accessing. MQ input and MB input and MB output is just a summary of files that the message broker is reading from or writing to. Input URLs and output URLs is a summary of the endpoints that message broker is listening is consuming. So is providing. So these are basically the web services of the URL connections that other consumers can invoke on message broker, and then this is a summary of the outgoing requests that message broker is looking to make external to the broker environment. All thrown exceptions is just a summary of the description and the names and the numbers of the exceptions, just to give which just gives people an indication of what the standard sort of exception naming is. So it looks like some of them have just using defaults and default messages, and default descriptions, default message codes, while others are using a variety of different message codes, or exception codes, I should say. Database input URLs is for when you're analyzing database, data power code. Data power output URLs are URLs that data power is actually accessing, which could actually be inside broker, but could also be external. And processes and locks are for the Sterling component, which we've run out of time to deal with, but that's one of the other flavors of the MB Precise plugin that looks at both the data power and Sterling code, applies rules and violations, and produces metrics for those. So unless anyone has any questions, we've just come in just under our 1 hour, which is good. So hopefully it allows everyone to get back to what they were doing. Again, if you have any questions, feel free to email me at Coding Tools, and just on our contact page. There's a contact and also I believe, and an email address which you can reach. Otherwise, it's just richard at bettercodingtools.com to reach me. I hope you've enjoyed our little webinar on message broker code quality. Hopefully you've learned a little bit about Sonar and Jenkins and whether or not this is something that's applicable to your everyday development in message broker. But hopefully it might transfer over to your development and development in other languages, which again Jenkins and SonarQube actually support as well as message broker. So thank you for your time, and I hope you got something and enjoyed this presentation.